Hello everyone and welcome to my very first ever daily shorts video. So this series I was thinking about doing just short videos, maybe like 5 minutes tops, for different types of questions that I really found interesting. Maybe it could be any subject, could be chemistry, it could be physics, could be maths, just in general anything that I found interesting personally myself and that could be relevant to our curriculum. So for this very first short, I decided to do one on calorimetry for level 3 chemistry. But this is more of a complicated example of calorimetry. But I personally found it very interesting. So let's have a look at this question. So we have cooling drinks on a hot day. So the question says, Jesse is getting ready for a trip to the beach with his friends, and he needs you to help him determine the number of bags of ice, 3 kilogram bags, that he needs to purchase from the supermarket. Jesse has 20 aluminium cans, so the mass of the cans are each 12.5 grams, and each of them will contain 355 milliliters of soda. He has forgotten to place the cans in the freezer the night before, so their current temperature is 25 degrees Celsius. So he wants to use the bags of ice so that the temperature of the soda can be reduced to 0 degrees. Since Jesse is broke, he wants to use the minimum amount of ice to do this. Therefore, the last bit of ice should melt just as the system reaches 0 degrees. For this calculation, we want to assume that the heat capacity of the soda is equal to that of ice and is equal to that of water, which is 4.18 joules per gram Celsius. The heat capacity of aluminium is 24.4 joules per mole Celsius, which is very similar to, it's just a different unit for our C value. So in this case, it takes 24.4 joules of energy to increase the temperature of 1 mole of aluminium by 1 degree Celsius. And we know that standard enthalpy of fusion of ice is 6.01 kilojoules per mole. So the standard enthalpy of fusion of ice is just the amount of energy that's required to convert 1 mole of water in its solid form, which is ice, into its liquid form, which is water. So how much ice is required and how many bags does Jesse need? Alright, so for this question, we want to consider all of the different types of energies in our system. So in this case, we want to reduce the temperature of the cans. We want to decrease the temperature of the liquid. So the total amount of energy we need is the total amount of energy required to reduce the temperature of the aluminium from 25 degrees to 0 and to decrease the temperature of the soda from 25 degrees to 0. The amount of the energy absorbed, which would be the increase of temperature of the ice, and we'll say that, I forgot to mention that the temperature of the ice starts at 8 degrees Celsius. So temperature initial of ice is equal to -8. Sorry about that. We can start the temperature of the ice at -8 degrees. So the total energy absorbed would be the total amount of energy to increase the temperature of the ice from -8 degrees to 0 degrees Celsius, and the further energy absorbed when the ice is converted into a liquid form. So just as all of the ice is converted into a liquid form, the temperature of the system reaches 0 degrees Celsius. So let's look at the amount of energy that needs to be absorbed in order to decrease the temperature of the soda and the cans down to 0 degrees Celsius. So we're going to use our formula, that's Q equals to mc delta T. So we're going to find out the total amount of soda that we need to decrease the temperature of. So in this case, we have 355 milliliters, which in this case, we can say is approximately just 355 grams, assuming 1 gram per milliliter density for water. So we can say that 355 is equal to 355 grams, and that's going to be multiplied by 20, because since we have 20 different cans of aluminium. So 355 times 20, that gives us 7,100 grams. So we can say that Q is equal to 7,100 times of the heat capacity, which is 4.18, times by the change in temperature, which in this case would be -25 degrees Celsius. Alright, and this gives us an answer of -741,950 joules. We'll leave that aside for now. And we'll also need to decrease the temperature of the aluminium cans by 25 degrees. So the total mass of the aluminium cans would be, so M of AL is equal to 20 times 12.5, which is equal to 250 grams of aluminium. So therefore, we can say that the molar amount of Al is equal to the total amount of mass, which is 250, divided by its molar mass, which is 27. and that's about 9.26 moles. So once again, we're going to use Q, I'll use different colors. So Q equals to mc delta T, and that is equal to the moles of aluminium, which is 9.26 times by 24.4. And the reason we have to convert this one to moles is because our C is given in moles per Celsius, okay? Because we want just the amount of energy to increase 1 mole of aluminium by 1 degree, okay? And that's also negative 25 degrees. And that's going to give us an answer of negative 5,648.6 joules. Alright, so let's so our total amount of energy that needs to be absorbed, we can just add it together. So we can say this is Q2 and this is Q1. Use another color, so we can say that Q total is equal to the sum of both of those energies, which is negative 747,596. 98.6 joules. Okay. Right, so now we have to look at the other. So what is absorbing the energy is the ice. The ice is absorbing energy and it's increasing the temperature of the ice so that it reaches 0 degrees Celsius. And then all the ice will then melt. And after it melts, it's going to, the system is going to reach 0 degrees Celsius. So after it melts, this much energy would have been absorbed by the ice. So we'll just say, let the amount of ice we have be X. So we can say, let mass ice equals to X. And we can use once again Q equals to mc delta T. So we have two. Okay, so basically the energy absorbed would be the Q required to increase the temperature of the ice, plus the Q required, the standard enthalpy of fusion. So that's the amount of energy required to convert that amount of ice into its liquid form. So we can say that's Qn. So those two added together is going to equal to our everything on the right hand side. All right, so looking at our the amount of energy required to increase the temperature of ice, we can say that Q equals mc delta T. So we can say that Q equals to mass, we don't know, times C, which is 4.18, multiplied by the increase in temperature, which is 8. Because our initial temperature of the ice is -8, so we're actually, so the change in temperature is positive, okay? All right, so that's our QI. And our Qn is just going to be the amount of energy absorbed when the solid ice melts. So we know that the standard enthalpy of fusion of ice is 6.01 kilojoules per mole. So therefore the mole of the amount of ice we have is equal to the total mass that we have divided by the molar mass of water, H2O, that is molar mass of 18. And so that's the number of moles of ice multiplied by the amount of energy, which is, in this case, is given as kilojoules, but since we've been working in joules throughout the problem, we're going to convert 6.01 kilojoules to joules, which is 6,010 joules. So that's 6,010. All right, so now let's just make a bit more room. So let me just get rid of this top part for now. All right, so we have 4.18 times 8 is 33.44. And that's added together with 333.89. Sorry, my writing's a bit messy. Times that mass, and that is equal to 747. And we can ignore the negative sign here because we know that the ice is going to be absorbing the temperature here. So it's going to absorb, so this much particular ice is going to absorb 747,598.6 joules of energy in order to lower the temperature of the system back to 0 degrees Celsius. So if we just solve for m, we can say 447.6. So we can say that mass is equal to 2,035.2 grams. So So therefore, since each bag is actually 3 kilograms, we can say that therefore Jesse actually only needs 1 bag of ice. Jesse only needs 1 bag of ice. Alright, and that's it for this question. So we found out the mass of ice that's required in order to lower the temperature of the system to 0 degrees. And that will be our answer. So Jesse actually only needs 1 bag of ice. So I hope you enjoyed this very first short, and I hope to see you all in the next video. Thank you. Bye.